Hello, we are in Chapter 5, Section 5.6, Rationalizing Denominators. In this video, we're going to go over rationalizing binomial denominators. Consider the following expression, 5 plus the square root of 6. We're asking the question, what do we multiply this by to get rid of the radical, the square root of 6 in this case? Well, we have to acknowledge that that square root of 6 is just an addend in here. So if we multiply this whole sum, 5 plus the square root of 6 by the square root of 6, then we will have to distribute that square root of 6 and we will still have 5 times the square root of 6 as one of the addends. So that's not what we want to do. We can't just square it. Well, that won't really do much. So we have to find something else. The question is, are we familiar with any kind of formula, operation, that performed on this sum will give us something with the squares? Well, there is the difference of squares that we are familiar with, and it is obtained by multiplying the sum of the bases of the original expressions by the difference of them. And since we have the sum of 5 and the square root of 6 in here, we want to multiply that by 5 minus the square root of 6. Let's do it. Well, according to our difference of squares formula, we are getting the square of 5 minus the square root of 6, which is 25 minus 6, which is 19. Well, what did you notice that happened? No more radicals. So whenever we are going to have a denominator of such form of the sum or difference of two numbers or expressions where one of them or both of them is the square root, then we would want to use exactly the same approach. Now we will say that 5 plus the square root of 6 and 5 minus the square root of 6 are called conjugates of each other. And in general, whenever we take the sum of two expressions and the difference of those expressions, we call that pair conjugates of each other. Summarizing, if a radical expression has a sum or difference with square roots in the denominator, we will rationalize that denominator by multiplying both the numerator and denominator of our fraction by the conjugate of the denominator.